Imagine you are weightless. Outside the window, the earth hangs in perfect silence. A blue marble wrapped in cloud, so impossibly beautiful that for a moment, you forget to breathe. You have trained your entire life for this. And right now, floating inside the Orion capsule at the edge of everything humanity has ever dared to reach, your body feels fine. Maybe better than fine. Calm. Weightless. Free. Then, a soft alarm. Not a screaming alarm. Not a crisis. Just a whisper from the medical monitor strapped to your wrist. A number that has quietly, without warning, begun to shift. You blink. There's a pressure behind your eyes. Subtle. Warm. Like the beginning of something you cannot name. You are only 18 hours into the mission. Artemis II, the first crewed deep space flight since 1972, hasn't even cleared the moon's orbit yet. And something inside your body has already begun to change. To understand what is happening to your body, you first need to understand where you are going. Artemis II will carry 4 human beings to a distance of approximately 370,000 kilometers from Earth, beyond the far side of the moon, further than any crewed mission since the final Apollo flight. To put that in perspective, if you were to drive a car around the Earth's equator, you would need to complete that journey 18 times before reaching the same distance. And you would be doing it inside a spacecraft roughly the size of a 2-story house. For decades, human beings have been going to the International Space Station, a gleaming outpost floating just 400 kilometers above the surface. Close enough that an emergency evacuation could bring a crew home in hours. Close enough that Earth's magnetic field, the invisible shield that protects all life from the lethal particle storms of deep space, still wraps around the station like a warm hand. Artemis II leaves that hand behind entirely. But the distance itself is not the danger. The danger is what the distance does to the body the moment you cross it. The moment gravity disappears, your cardiovascular system does something extraordinary and quietly catastrophic. On Earth, your heart has spent its entire existence fighting gravity, working constantly to push blood upward against the pull toward your brain. In zero gravity, that fight ends in an instant. The fluid that your body has spent a lifetime learning to manage suddenly has nowhere to go, and so it rises. It floods upward into your chest, your face, your skull. Astronauts describe it as feeling permanently upside down. Your face puffs. Your sinuses fill until breathing becomes labored. Food loses all taste because your nasal passages are perpetually swollen. And behind your eyes, that warm, building pressure grows steadily stronger with every hour. But here's the problem. That pressure isn't just discomfort. It is your brain, slowly, invisibly, pushing against the back of your eye. Scientists call this condition VIP syndrome, spaceflight-associated neuroocular syndrome. MRI scans of astronauts returning from long-duration missions reveal optic nerve sheets swollen with fluid, optic discs pressed flat, and in some cases, eyeballs that have been physically deformed, squeezed into new shapes by the relentless pressure from within. Real data point: a significant percentage of astronauts who served aboard the ISS reported measurable vision changes after their missions. Some needed glasses for the first time in their lives, and for several, those changes never fully reversed. There is no pain. No warning you can feel coming. Just a quiet, invisible force reshaping the architecture of your vision, and you will not know how severe it is until you are standing on solid ground again, blinking at a world that no longer looks quite the same. But that is only the beginning. Bone is not static material. It is living tissue, constantly rebuilt, constantly dissolved, in a biological conversation with the mechanical stress your body places on it every single day. Stand up. Walk. Carry weight. The skeleton listens and it reinforces itself accordingly. Remove that mechanical stress, as spaceflight does completely, and the conversation goes silent. Bone-building cells stand down. Bone-dissolving cells keep working. In microgravity, astronauts lose bone mineral density at a rate of 1 to 2% per month. The same rate seen in elderly patients with severe osteoporosis. The crew of Artemis II will exercise 2 hours every day without exception, not for fitness, but simply to slow the collapse of their own skeletons. But the structural breakdown is only one dimension of the crisis. Deep inside the immune system, something older and stranger begins to wake up. Most human beings carry dormant viruses, Epstein-Barr, varicella-zoster, the herpes simplex family, locked away in nerve tissue, suppressed by a healthy immune response for decades. In space, the immune system loses its coherence. White blood cell populations shift. Surveillance mechanisms falter. And the viruses that have been sleeping inside astronaut bodies for 30-40 years, they begin to stir. During spaceflight, astronauts shed active viral particles in their saliva and tears. They are, in a clinical sense, becoming contagious with their own suppressed history. In a tin can 4 days from any hospital with no evacuation window, there is no one to call. And this is where things become truly terrifying. Because none of that, not the fluid shift, not the bone loss, not the immune collapse, is the most dangerous thing waiting for the crew of Artemis II. That distinction belongs to something you cannot see, cannot feel, and cannot stop. Beyond the Van Allen belts, the magnetic radiation shields that cocoon the Earth and everything close to it, the spacecraft enters a zone of galactic cosmic rays. These are not the gentle radiation of an X-ray machine. They are atomic nuclei, iron, silicon, carbon, forged in the depths of stars billions of years ago, traveling at a significant fraction of the speed of light. They pass through the spacecraft walls as if they are not there. They pass through the human body the same way. The Apollo astronauts described seeing flashes of light with their eyes closed. Cosmic rays firing directly through their retinas in the dark. The crew of Artemis II will see the same flashes, and carry the same invisible damage home with them. A single deep space mission delivers a radiation dose equivalent to years of medical CT scans. The elevated cancer risk is measurable, quantifiable, and permanent. Here is what makes all of this so deeply unsettling. Nothing is malfunctioning. The human body is performing exactly as designed. Think of your cardiovascular system as a building's plumbing, engineered over millions of years to move fluid upward against gravity to the brain. Lay that building on its side and the plumbing still runs. It runs perfectly. In exactly the wrong direction. Think of bone as a living conversation between stress and structure. Remove the stress, as weightlessness does, completely and immediately, and the structure begins quietly dismantling itself, the way an unused road crumbles without traffic to justify its maintenance. The immune system, similarly, evolved in an environment of constant microbial challenge, circadian rhythm, and gravitational orientation. Strip away all three and the system's threat assessment logic begins to drift. None of this is the body failing. It is the body succeeding, optimizing for an environment that no longer exists. And that may be the most frightening thing of all. You cannot fix a system that believes it is working correctly. And the threats don't stay separate. They feed each other. Intracranial pressure impairs vision, reducing the crew's ability to read instruments and perform manual maneuvers. Bone loss weakens the musculoskeletal structure needed for an emergency spacewalk. Immune suppression accelerates viral reactivation, which triggers inflammation, which further disrupts sleep. And sleep deprivation independently degrades cognitive function, reaction time, and emotional regulation. The cascade doesn't stop. Each thread pulls another loose. We are not guessing at any of this. We have evidence. In 2015, NASA astronaut Scott Kelly spent 340 consecutive days aboard the International Space Station while his identical twin brother Mark remained on Earth. When Scott returned, researchers compared the two men down to the molecular level, and what they found changed the way we understand human spaceflight entirely. Scott's telomeres, the protective caps on chromosomes associated with aging, had actually lengthened in space, then rapidly shortened upon his return. His gene expression had changed. His gut microbiome had shifted. His cognitive performance showed measurable decline. 91% of those changes returned to baseline after he came home, but 9% did not. Some modifications appear to be permanent. Scott Kelly went to space and came back, genetically, a slightly different person. And then there are the Apollo numbers. A 2016 study examining the long-term health of Apollo astronauts, specifically those who traveled beyond Earth's magnetic field, as the Artemis II crew will, found that they died of cardiovascular disease at 4 to 5 times the rate of astronauts who never left low Earth orbit. The sample size is small, but the signal is not. The crew of Artemis II has read all of this. Every paper, every study, every number, and they are going anyway. Because here is what makes Artemis II unlike anything that has come before it. There is no long-duration deep space human physiology data. The last time anyone traveled this far was Apollo 17 in 1972, a mission that lasted just 12 days. Artemis II will go further, stay longer, and carry medical monitoring technology that didn't exist in the Apollo era. The crew will not just be making history. They will be generating the data that determines whether human beings can survive the next step, Mars, the asteroid belt, the outer planets, at all. They are not just explorers. They are the experiment. Step back. Go further than the spacecraft. Further than the moon. As far as we know, no organism in the 4 billion-year history of life on this planet has ever voluntarily left its biosphere. Every living thing that has ever existed, from the first single-celled organisms in the primordial ocean to every human being who has ever drawn breath, has done so inside the same protective envelope. A specific gravity, a specific magnetic field, a specific atmospheric pressure, a specific radiation diet. We are, all of us, creatures of a very particular set of physical conditions. Conditions that Earth has maintained, with remarkable consistency, for almost as long as the planet has existed. We are the first life form to notice that envelope exists, and the first to step outside it on purpose. The universe, it turns out, did not design itself around the needs of human tissue. The forces that shaped us are profoundly local, and profoundly lucky. A slightly different stellar neighborhood, a slightly weaker magnetic field, a slightly closer star, and the biological experiment that produced us never begins at all. We are standing, right now, at the absolute frontier of what our biology permits. Not what our technology permits, what our bodies can survive. And Artemis II is the first honest reckoning with that limit since the Apollo era. You are still weightless. The Earth is still in the window, smaller now, receding, a circle of light in the dark. The pressure behind your eyes hasn't faded. It won't. Somewhere between the data and the silence, there is a decision that no scientific paper can fully explain. The decision to go anyway. To accept the transformation. To trade something measurable and permanent of yourself for the view from the other side of the moon. Every explorer who has ever crossed an ocean without a map, climbed beyond the treeline into the thin air, or walked into a wilderness that had no name has carried some version of this bargain. The body remembers what the mind decides to risk. The body keeps the receipt. But the alternative, to stay always within the envelope, to never test what lies on the other side of the shield, is its own kind of loss. A species that stops at its own horizon is a species that has decided it already knows everything worth knowing. The universe is not hostile to life. It is simply indifferent to it. The conditions that permit human existence are local, temporary, and profoundly specific. The moon is not far. It is already far enough to remind us how small the window is that makes us possible at all. The universe will not come to us, and so, body by body, transformation by transformation, we go to it.